Let me read the question now. Diagram 4 shows a trapezium PQRST. QS is parallel to PT. As you can see here, this is a trapezium shape, and they gave us an additional information that QS is actually parallel to PT. And if you take a close note, PQST itself is actually a rectangular shape. Okay, so continue to read the question. It is given that TR is equal to 26 centimeter. Okay, TR itself is 26 centimeter. QS is equals to X centimeter. So the vertical length QS is equals to X centimeter, and SR is equals to 2X centimeter. Okay, this is the length SR, which is 2X centimeter. Okay, so let me read the question A part 1. State the area in centimeters square of PQST in terms of X. Okay, and then for the part 2, hence find the maximum area in centimeters square of PQST. So that is for the question part A. For the part B, given that the rate of change of the area of PQST is 36 centimeters square per second when X is equals to 5 centimeter. Calculate the length in centimeter of QS after 3 seconds. Okay, this is for the part B. Okay, for the part C, find the approximate change of the area in centimeters square of PQST when the value of X changes from 2 to 1.98. Okay, so this is the overall question of question number 8. Okay, as you can see here, this question 8 is consists of the differentiation concept. Okay, where you can see here you have a concept of chain rule, small changes and approximation, and then the differentiation. Okay, the application of turning point. Okay, so without further ado, let us begin our discussion for the question 8A part 1. Okay, for the question 8A part 1, okay, so to find the area in centimeter of PQST in terms of X, okay, we need to be clear on the information that given by the question. Okay, so TR is equal to 26. Okay, this 26 is representing the whole length from T up until R. Okay, and then they gave us that SR itself is equals to 2x centimeter. So that means S until R, the length is 2x. Okay, that means to find the length of TS, basically it is 26 minus with 2x. So that will be the answer of the length of TS. So that will be the first step. 26 minus with 2x. Okay, and believe it or not, when you combine these two lengths, you will get back the original answer, which is 26. Okay, so 26 minus 2x and then plus with 2x, the negative 2x and 2x will get cancel off, and that's how you get 26. Okay, so from here, so this is your first step to get the length, because we already have the vertical height and we are required to find the horizontal length, which we just find the horizontal length. Okay, now we have two lengths. Okay, that is sufficient for us to find the area in centimeter square of PQST. Okay, so from here let us calculate the area PQST. Okay, area PQST is equals to, okay, the formula is the rectangle formula, okay, which is length times with width. Okay, so from here the length is 26 minus 2x, okay, and then times with the width, which is the length, vertical length, which is in this case is x centimeter. Okay, so from here you expand the bracket. From here you should get your area PQST is equal to 26x minus 2x square. Okay, let me close bracket. Okay, and make sure write the unit. Okay, the unit is very important. Please have the practice. Okay, otherwise your marks might get deducted. Okay, so let me underline the solution for the question A part 1. Okay, very straightforward. Basically you just need to apply the rectangle formula, but before that you need to know how to get the length first. Okay, so from here we're done with the question A part 1. Let us move on to the question A part 2. Okay, by finding the maximum area in centimeter square of PQST. Okay, as the continuation from the part 1, so by using the area which we find, the area PQST. So we are required to find the maximum area in centimeter square. So how are you going to find the maximum area? Okay, so one of the application of differentiation or derivative that we can apply over here is we can use the differentiation. From there we can able to find the maximum area. So how are you going to do that? We're going to apply the turning point concept. Okay, so when you want to find anything which is maximum or minimum, so you set your differentiation or derivative is equals to 0. Okay, in this case you set your area with your differentiation of area with respect to x is equals to 0, and from there we can able to get the maximum area. Okay, so this is the overall idea on how we're going to solve for the question A part 2. So let us start the working together. Okay, so from here, so I'm just going to write the area as A. Okay, it is understood that we are finding the area for PQST. So from here A is equals to 26x minus 2x square. Okay, so from here we're going to differentiate the area with respect to x. So from here dA over dx is equals to 26 minus 4x. Okay, so from here, in order to find maximum area, so we're going to set our dA over dx equals to 0. Remember what I've told just now, turning point concept. Okay, so from here, for A max, so we're going to set dA over dx equals to 0. Okay, so dA over dx we already find, which is 26 minus 4x. So we're going to make it equal to 0. So from here 26 minus 4x equals to 0. 4x equals to 26. Okay, to find your x, what you're going to do, 26 you divide with 4. So you calculate this, you should get your x is equals to 6.5 centimeter. Okay, remember guys, don't forget the unit. Okay, let me underline this. Okay, this is not the final answer, it's just a part of the working. Okay, so once you get this, so what you need to do is you need to use this x value and then substitute into the equation of the area. Okay, to find the maximum area, or in this case A max. Okay, so from here when x is equals to 6.5 centimeter. Okay, so from here A maximum will be equals to 26. Okay, and then times with 6.5. Okay, and then minus with 2 times with 6.5 square. Okay, so you calculate this. Okay, you should be getting your maximum area is 84.5 centimeter square. Okay, so let me underline the solution for the question A part 2. Okay, so we're done with the question part A. So let us proceed our discussion for the question part B now. Okay, so for the question part B, given that the rate of change of the area of PQST is 36 centimeter square per second when x equals to 35 centimeter, calculate the length in centimeter of QS after 3 seconds. Okay, so this question is involving the chain rule concept. So we're going to apply the chain rule concept to solve this question. Okay, but before that, let us write down all the information that given by the question into our working here. So let me scroll this down. Okay, so given that dA over dt is equals to 36 centimeter square per second, and then they also give that the x is equals to 35 centimeter. Okay, so from here we are going to form a chain rule of dA with respect to dt. Okay, so how are we going to form a chain rule with respect to this expression where dA over dt by area with respect to time? So from here, so dA we're going to place it at the numerator, whereas dt we're going to place it as the denominator, which at the right side. Okay, and over the top and bottom over here we're going to replace with dx. Okay, so this formation of the chain rule is very important for us, and once you get this correct, then only the next step will be correct as well. Okay, so let me box this. So from here, dA over dt we already get from the question itself, which is 36 centimeters square per second. So let me write it down over here. So 36 is equals to dA over dx. Okay, so from here dA over dx, so from here it is equals to 26 minus 4x. Okay, 26 minus 4x, which we already find through the working. Okay, 26 minus 4x. Okay, instead of writing here x, we're going to substitute x as cert5 over here. So from here x will become cert5. Okay, and then you times with dx over dt. So this is the one we are going to find now, since we don't know the actual value yet. Okay, so from here, in order to find dx over dt, so 36 we're going to divide with 26 minus 4 times with cert5. Okay, so you do the division. Okay, you calculate it. So from here you get dx over dt is equals to 2.11 centimeter per second. Okay, so let me underline this. Okay, basically this is our step 1 to get the dx over dt. Okay, but then the question already gave us the clue that to find the length of the PS, if I'm not mistaken, it's QS. Okay, the length of QS after 3 seconds. So that means that you need to find the equation of x in terms of t. So how are you going to do that? So we're going to integrate this with respect to time. Okay, since we got here the differentiation of x with respect to t, now we need to form an equation of x in terms of t. So for that we need to perform the integration. Okay, so from here x will be equals to integration of dx over dt with respect to time. Okay, so from here x is equals to integration of 2.11 respect to time dt. Okay, you perform the integration, so from here you get x is equals to 2.11 t, and make sure, since we are dealing with indefinite integral, plus with the constant c over here. Okay, up until now I hope the students are clear about the steps and working over here. Okay, so for the next step we need to find the value for c constant over here. So how are you going to find the value for the constant? So in order to find the constant value, you need to get two information, which in this case one of the value x and one of the value t. Okay, for the value x we already have the cert5, so we can substitute over here. But how about the value t? Okay, so for the value t, okay, read the question carefully. The question mentioned us that rate of change of the area PQST is 36 centimeters square per second when x equals to cert5, and then they ask us to calculate the length of QS after 3 seconds. So we can assume that in initial time, when t is equals to 0, your x is equals to cert5. So from here we can conclude that when t is equals to 0, x equals to cert5. Okay, so from here we got our information, t is equals to 0 and x is equals to cert5. So we can use these two information and then substitute into our equation over here. So from here cert5 is equals to 2.11, okay, and then times with t, in this case is 0, plus with c. So from here you calculate this, you get your c is equals to cert5. Okay, so from here This is your C. Okay, and now we already formed the equation of x, which in this case your x equation will be equals to 2.11 t plus with set 5. Second, set 5. Okay, so let me underline this, but this is not the final answer. Okay, we still have one more step left. Okay, since the question asks us to find the length of QS after 3 seconds, that means that we need to find the respective x value when t is equal to 3. So from here, when t is equals to 3, so from here x will be equals to 2.11 times with 3 plus with set 5. Okay, so you calculate this. So from here you get your x is equals to 8.57 centimeter. Okay, now we are done with the question part B. Okay, so let us proceed to our last question, which is the part C. Okay, where we're going to apply the small changes and approximation concept. Okay, in the question they already gave us the x original, which in this case is 2 centimeter, and the new x value, which in this case is equals to 1.98 centimeter. Okay, so from here we are required to find the small changes that occur for x. So we can denote it as delta x. So to find the delta x is very simple. The new value you minus with the original value. So from here 1.98 you minus with 2. So from here you get your delta x is equals to negative 0.02. Okay, so from here we already get the delta x, which is the small changes in x. Now we need to find the small changes in area. So how are you going to do that? We're going to apply the small changes in approximation formula, which in this case small changes in area divided with small changes in x will be approximately similar to dA over dx, which in this case differentiation of a with respect to x, or derivative of a with respect to x. Okay, so from here let me box this formula. Okay, this is the formula that you're going to apply to solve the question part C. Okay, so are we good? So from here to get the delta A will be approximately equal to dA over dx times with delta x. Okay, so from here delta A will be approximately equals to, so from here 26 minus with 4 x. Okay, so the substitution of x value, you need to be careful. Okay, make sure that you substitute the original value into the equation here, not the new value but the original value. So in this case the original value is 2 centimeters. So what you do, you substitute 2 over here. Okay, so 26 minus 4 times with 2 times with delta x. Okay, delta x in this case is negative 0.02. You just times with negative 0.02. So from here you get your small changes in area, which is approximately equal to negative 0.36 centimeter square. Okay, so this is your answer for the question part C. So let me underline the solution for the question part C. Okay, okay, the question, the student can also ask me, so for the final answer for the question part C, can I express in terms of fraction? The answer is yes, you can. Okay, but in this case I express in decimal. It doesn't matter, guys, as long as your final answer is correct. Okay, so let me scroll the question up. So from here we have come to the end of the discussion of question number 8 SPM 2021 Add Maths paper 2. Okay, if you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming Add Maths tutorial videos in the future, and make sure that you share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.